Hi everybody, here's a little bit of help on Chapter 8 Simple Machines practice problems. I'm going to do number 1 as a full example. Okay, Eric is using a lever to lift a 20 kilogram box which lies at a distance of 0.5 meters from the fulcrum. Pushes down on the lever with a 50 Newton force. What distance is Eric from the fulcrum? Okay, so I'm going to need a little diagram here. So here's the fulcrum, here's the lever, here's the box that's been lifted. Now I'm going to label some things on my diagram. So there's a force in, that's how hard he pushed on the lever, and there's a force out. That is going to be equal to the weight of the box. And there's the D out, which is the distance from the lever, and there's the D in, that's the distance from that Eric is from the fulcrum. Okay, I'm going to get down some knowns now. What am I given in the problem? I'm given a mass of 20 kilograms for the box, and I need a weight for the force out, so I'm going to use G, 10 meters per second squared, and I'm going to find my F out, which is the weight of the box. So that's going to be equal to the mass times G, M times G, so 200 newtons, because 200 kilograms times 10 meters per second squared. So there's my F out. Okay, I'm also given my F in. We're told that he's pushing with 50 newtons. Alrighty, so now I'm going to look at my distances. So I'm given some values here. We're told that on the output side that the box is 0.5 meters from the fulcrum, and we're asked what distance is Eric from the fulcrum, so that would be D in, and that's going to be our target variable. Okay, so then I need to find the mechanical advantage in order to answer this problem. So then the mechanical advantage is equal to the output force over the input force, and it's also equal to the input distance over the output distance, so how the machine is built. So I have both these forces, and I have D out, so then I can solve for D in here. Okay, so then my D in is just equal to F out over F in times D out. Okay, so plugging in my numbers. My output force is the weight of the box, 200 newtons. Input force is how hard he was pushing, 50 newtons. And then that's going to be multiplied by the output distance, which is 0.5 meters. So using my calculator, I end up getting an output distance, or excuse me, an input distance of 2 meters. Okay, so next question, it says, what is the mechanical advantage of this lever, and what does this number mean? Okay, so then this I means ideal mechanical advantage. So this is our theoretical mechanical advantage. So that's based on how the lever is built. So that's our D in over D out. So then we have our new D in we found is 2 meters, D out was 0.5 meters. So that's going to give a mechanical advantage of 4. What does this number mean? It means ideally the lever multiplies the input force by 4, which makes the user 4 times as strong. Okay, and the next question asks us what's the actual mechanical advantage of the lever. If Aaron actually pushes with a force of 75 newtons, instead of the 50 newtons. So there must have been a little friction acting if he or she took 75 newtons to push down instead of 50. So what does that number mean? Okay, so let's find the actual. So the actual mechanical advantage is equal to the output force divided by the input force. Okay, the output force is the weight, 200 newtons. Now the input force, we're told this time, is 75 newtons. So whenever we crank through our calculation there, we end up getting about 2.5